The following table gives data on new private cars sold in Ireland in each quarter of each year from 2006 to 2011. So there's 12 months in a year and a quarter of 12 is 3, so it means each quarter means for each 3 months. So January, February, March is a quarter, that's 3 months. April, May, June, that's another quarter. July, August, September, that's another quarter. October, November, December. So we have 1, 2, 3, 4 quarters. So we see we have the years from 2006 down to 2011. This tells us the number of cars sold. So for example, in 2006, from January to March, there was 75,769 cars sold. Then we move along and we get the annual total. So 75,769 plus 54,572 plus 32,873 plus 10,059 gives us 173,273. So that's the annual total, so the yearly total of number of cars sold in 2006. Over here we have the engine type of cars sold. So in 2006 there was 128,634 petrol cars. In 2006, there was 44,010 diesel cars. And in 2006, there was 629 other, so maybe electric or hybrid. So A, part 1, show the annual total sales of cars over the 6 years using a suitable chart. So we're going to create a bar chart. We're going to use the years, 2006 to 2011, and the totals. So for example, 2006 will go up as far as 173,273. 2007 will go up as far as 180,754, and so on. So we're going to have 6 bars because we're focusing in on 6 years. There are 6 years in our table. So here's our bar chart. Here's our years along the bottom, 2006 to 2011. So this is our x-axis, and along our y-axis we go from 1 to 18. And this is just to save us a bit of time and a bit of space. We know the numbers are much bigger than 18. So for example, 2006 we know is 173,273. So our y-axis is annual total sales out of 10,000. So for 173,273, we want to just go above 17. So that's 2006. So likewise for 2007, we want to go to just over 18. So we've gone just over 18 for 2007. For 2008, we want to go to about 14.5, or just over 14.5. So 2008 goes to just over 14.5. 2009 goes to just under 54.5, or 5.5. So 2009 is just under 5.5. 2010 is just under 8.5. So 2010, just under 8.5. And 2011, over 8.5. So there's 2011. So closer to 9 than it is to 8. Now really important rules about bar charts. The bars must be of equal width. So notice that each of these bars is 2 boxes wide. The gaps in between must also be of equal width. So these gaps happen to be 2 boxes wide, just like the bars themselves. And for a bar chart, the bars are not stuck together. Also, make sure that your y-axis goes up in the same units. So we're going up in ones, so we have to continue up in ones. So you couldn't go 1, 2, 3, 4, 5, and then go 6, 8, 10, 12. So you couldn't start going up in 2s all of a sudden. You have to go up in the same amount. Part 2, find the mean number of cars sold per year over the 6 years. So for mean, we're going to add them together and divide by the amount. So we're going to divide by 6. So we add the totals together and then we divide by 6, or in this case you can multiply by a sixth, which is the same thing. So adding them all up we get 726,768, and dividing by 6 we get 121,128. So this is the mean number of cars sold. So remember, multiplying by a sixth is the same thing as dividing by 6. Part 3. Calculate the percentage increase in annual car sales between 2009 and 2011. So in 2011, there was 86,932 cars sold. In 2009, there was 54,432 cars sold. So subtracting, we get 32,500. So this was the difference. So this was the increase. So to get the percentage increase, we're going to take that number, the difference, the increase, and we're going to divide it by 54,432. And we multiply by 100 for a percentage, so we get 59.71%. So this was the percentage increase. 4. Aoife says that this increase shows car sales are currently going well. Paul says that car sales are currently going bad. He says that sales have fallen by 52% since 2007 and that they are well below average. Complete the sentences below to give a criticism of each argument. So let's start with Aoife. So Aoife says that this increase shows car sales are currently going well. Well, Aoife's argument does not recognise that this increase comes from a very low base and that sales had been much better before 2009. So here's 2009 and the total number of sales was 54,432, whereas in 2006 it was 173,273, in 2007 it was 180,754, and in 2008 it was 146,470. So before 2009 the sales were much better. Paul says that the car sales are currently going badly. He says sales have fallen by 52% since 2007 and that they're well below average. So Paul's argument does not recognise that although sales are lower now than in 2007, they have recovered a lot since their lowest point of 2009. So in 2007, yes, the sales were very good, 180,754. And now in not now, at the present moment when this exam was written, in 2011, the sales were 86,932. So yes, they're a lot lower than they were in 2007, but they have increased since 2009, where they were only 54,432. Part 5. Give a more balanced description of the pattern of car sales over the 6 years. Well, we can say that sales fell dramatically from 2007 to 2009. So in 2007, there were 180,754. And in 2009, they fell dramatically to 54,432. A massive drop. They recovered a lot since then, but are still much lower than they were at the start. So they have recovered a lot. So 86,932 is a lot higher than 54,432. But still not as high as they were at the start, which is 173,273. B. Part 1. Describe how the sales of the cars are distributed over the 4 quarters of each year. So the highest quarterly sales are in the first quarter. So January to March, the sales are much higher. So let's start with 2006. 75,000 January to March. Then a drop to 54,000, a further drop to 32,000, and a further drop again to 10,000. Likewise, in 2007, started off in the first quarter 81,000, dropped to 57,000, dropped again to 32,000, and dropped again to 9,000. And this repeats the whole way down to 2011. Starts at 39,000, drops to 29,000, drops again to 13,000, drops again to 4,000. So the highest quarterly sales are in the first quarter. They decrease significantly in each subsequent quarter. So as the year goes on, the sales drop quite a lot. Part 2, suggest a reason for this pattern in sales. So why is it that lots of cars are being sold from January to March and then the sales drop drastically after that? People like to buy new cars early in the year so that they have a new year number plate. 3. The sales for the first quarter of 2012 are 36,081. Find with justification, so explain why, an estimate for the total annual sales for 2012. So remember that our table goes from 2006 to 2011. It doesn't go up as far as 2012, but we were told that the sales for the first quarter of 2012 are 36,081. So remember, this is the first quarter, January to March. First quarter sales in 2012 are about 1/3 of the range between those quarters in 2010 and 2011. So in the first quarter, January to March for 2010, there were 34,555 cars sold. So we draw out a number line for ourselves. This is 34,000, 35,000, 36,000, 37,000, 38,000, 39,000. So 34,555 is about here. It's a little more than halfway between 34,000 and 35,000. So this is 2010. The number of sales in 2010 for the first quarter. In 2011, the car sales for the first quarter were 39,484. So if this is 38,000, this is 39,000, then about here would be 39,484. So that's about where 2011 is. So the number of car sales for 2011 is about here. We are told in the question that in 2012 there was 36,081 cars sold in the first quarter. If this is 36,000, this is 37,000, then 36,081 is about here. So this is the number of car sales for 2012 in the first quarter. And we can see that this is about 1/3 of the way across from 2010 right the way to 2011. So first quarter sales in 2012 are about 1/3 of the range between those quarters in 2010 and 2011. If we're starting here and going up as far as here, we're about 1/3 of the way across. And that's across the whole range. Assuming annual sales will retain that proportion would give an estimate of 85,500 for annual sales. So where did this number come from? Well, the range is approximately 2,000. And that's of total sales. So in 2010, the annual total was 84,907. In 2011, the annual total was 86,932. So the difference is about 2,000. So the increase was about 2,000. So the range is approximately 2,000. So we're going to get 1/3 of 2,000, which is 666.6 recurring. And we're getting 1/3 of it because remember, the increase from 2010 to 2012 was about 1/3 of the range from 2010 to 2011. So we get 1/3 of the total range. So the total range was 2,000. So then we're going to add 666.6 recurring to 84,907. And we get 85,573.6 recurring, which rounds off to approximately 85,500. So using the data from the first quarter, we can make an assumption about the annual total by using the annual totals that were given for 2010-2011. So we assume that in 2012, so our estimate for the total number of cars sold was 85,500. See Part 1. Two pie charts are being used to show the change from 2006 to 2011 in the popularity of petrol and diesel cars. Complete the second pie chart. So here's the first pie chart. So we see for 2006 there was 74.2% petrol cars sold, there was 25.4% diesel cars sold, and this was the other. So we need to create the pie chart now for 2011. So the first thing we have to do is go to 2011, because that's the pie chart we have to fill in, and add up the amounts. So for petrol, there were 23,246. We're going to add that to the diesel, which is 61,730, and add that to the others, which was 1,956, which gives us 86,932. So this is our total. So for diesel, we're going to divide the amount of diesel cars, so 61,730, by the total amount, so 86,932. And we multiply by 360 because there's 360 degrees in a full circle, and we get 256 degrees. Then we do the same with petrol. So the number of petrol cars was 23,246. Divide that again by the total, 86,932. Multiply by 360 again because there's 360 degrees in a full circle. We get 96 degrees for petrol. Then we do other. Now the order in which you do this doesn't matter. So other is 1,956. Again, divide that by the total, 86,932. And again, multiply by 360 because there's 360 degrees in a full circle. And we get 8 degrees. So this line was drawn in for us already, so this can be our starting point. So we place our protractor down. We make sure that the centre of the protractor is in the centre of the circle, and that the line goes right along our zero line, so our line that joins up 0 and 180 degrees. So the edge of the protractor, so the diameter of the circle of the protractor, will go straight down, and we measure from here and we go right the way along until we get to 96 degrees. So a right angle would be here, so 90 degrees would be here, so 96 degrees is just a little above that. So make sure you take the acute angle and not the obtuse angle. So we mark where 96 degrees would be on our protractor. We take away the protractor and then we join up that mark to the centre of our circle. And we write in 96 degrees and petrol, because remember 96 degrees represents petrol. Next we can go for other. So other was 8 degrees. So you rotate your protractor. So again, the centre of the protractor must be in the centre of the circle, and this time your line must go along your new line. So this is the line that joins up 0 and 180 degrees. So the centre of your protractor goes in the centre of your circle, and the side of your protractor, which would be like the diameter of your semicircle, goes along this line. And then you count 8 degrees, which is only a very small acute angle, and you mark a point outside your circle which matches up with 8 degrees, and then you join that again to the centre of your circle. And I've left the biggest angle until last because 256 degrees is difficult to draw because it's bigger than 180 degrees. So all we have to do is just check that this remaining angle is 256 degrees, because the three angles together should add up to 360 degrees because there's 360 degrees in a full circle. So just measure this last remaining angle and check that it is 256 degrees, and then you know that you did your other two angles correctly. So how we measure this? Well, we can see that if we were to put a line straight down, we would have 180 degrees. So a semicircle, a line straight down, would give us 180 degrees. And then 256 degrees, take away 180 degrees, leaves us with 76 degrees. So if we were to imagine a line straight down, that would be the 180 degrees. So the leftover angle, so we're going from here around to here, should be 76 degrees. Which of the following statements best describes the change over time in the popularity of diesel cars as a percentage of the total? A. Diesel cars have suddenly become very popular in the last year or two. B. Diesel cars have increased very steadily in popularity over the last 6 years. C. Diesel cars have become very popular since car sales started to improve. D. Diesel cars got more popular each year with an especially big increase in 2009. E. Diesel cars became popular as car sales fell but have been getting less popular as they rise again. Write the letter corresponding to the correct answer in the box. So we're going to go with D, which states that diesel cars got more popular each year with an especially big increase in 2009. So if we have a look, here we have 2009 and here we have diesel cars. So there was 30,645 cars sold that were diesel in 2009, and this was 56% of the total sold. So this statement is correct. Diesel cars got more popular each year. So we can see diesel started at 44,000, then 50,000, then 50,000, then 30,000, then 53,000, and then 61,000. So they got more popular each year, but there was an especially big increase in 2009. And although 30,000 is less than 50,000 and less than 50,000 and less than 44,000, 30,645 is 56% of the total, which is 54,432. So remember, in 2009 there was a low number of cars sold altogether. But of the 54,000 cars that were sold in 2009, a very high percentage of that was diesel. D. A survey of some of the most popular models of private cars sold in 2011 examined the CO2, so carbon dioxide emissions, in G per K, so per kilometre, from diesel engines and petrol engines. The data are as follows. So diesel engines, we have 2, 4, 6, 8, 10, 12 data values, and petrol engines we have the same amount. Number 1, construct a back-to-back stem and leaf plot of the above data. So I'm going to start off by drawing an unordered stem and leaf for both, and in the next slide I'll show you the ordered stem and leaf, because our stem and leaf diagram must always be ordered. So let's have a look and see what is the lowest value. So 107 is the lowest value I see, and then the highest value, 159. So our stem needs to go from 10 to 15. So I'm going to start on the right hand side with petrol. So the first petrol data value I have is 139. So I write a 9 beside the 13 and tick off 139. It's very important that you tick off your values as you use them so that you don't forget about a value or else use one of them twice, which can easily happen. Then we have 133, so I put a 3 beside the 13, tick it off. Then 150, so a 0 beside the 5, tick it off. Then 157, so a 7, tick it off. 138, tick it off. 159, tick it off. 129, tick it off. 138, tick it off. 134, tick it off. 129, tick it off. 129 again, tick it off, and 136. Now I'm going to do the same on the left hand side for diesel engines. So 117, so I'm going to put a 7 to the left of 11, tick it off. 125, so a 5 to the left of 12. 120, so a 0 to the left of 12, and so on. 125, tick it off. 134, tick it off. 110, tick it off. 118, tick it off. 114, tick it off. 119, tick it off. 119 again, tick it off. 116, tick it off. 107, tick it off. So now what I have to do is rewrite them in order from smallest to largest on the right hand side, and from largest to smallest on the left hand side, because the lowest values have to always be closest to the stem. So on the left hand side, the 7 just stays where it is, and then to the left of 11 we have 0, 4, 6, 7, 8, 9, 9. So the numbers are lowest closest to the stem, and they get larger as we move to the left. Then beside the 12 we have 0, 5, 5. So again, the lower number is beside the stem, and the numbers get bigger as we move to the left, and then we just have a 4 in front of the 13. For the 12 on the right hand side we just have 9, 9, 9, nothing changes there. Beside the 13 we have 3, 4, 6, 8, 8, 9. So again, the numbers are lowest closest to the stem, and this time they get bigger as we move to the right. And likewise for beside the 15 we have 0, 7, 9. So 0 is the lowest, so that's beside the stem, and we get bigger as we move to the right. And don't forget to include a key. You will lose a mark if you forget a key. So 12/9 represents 129. You can pick any numbers for your key. Does the information suggest that diesel engines produce lower CO2 emissions, so carbon dioxide emissions, than petrol engines? In your answer, you should refer to the stem and leaf plot and to an appropriate measure of central tendency. So does the information, so does our stem and leaf diagram, suggest that diesel engines produce lower carbon dioxide emissions than petrol engines? So remember, diesel is on the left and petrol is on the right. So does our stem and leaf suggest that diesel engines produce lower emissions than petrol? And the answer is yes. The diesel engines grouped at the top of the plot have a smaller median or mean value. So to get the mean, what we'd have to do is add these values together and divide by the amount, which is 12. Now this does not mean 7 plus 9 plus 9 plus 8 and so on. This means 107 plus 119 plus 119 plus 118 and so on. So adding up all the values, including the stem parts, and then dividing by 12 because there's 12 of them. To get the median, we get the middle value. So what we can do for the median is cross off the first and last, and then the first and last, and then the first and last, first and last, first and last, and then we're left with two values in the middle, which is 119 and 118. So we add them together, divide by 2, we get 118.5. So now I'll do the same for the petrol engines. So I'll mark off the first and the last, first and last, first and last, first and last, first and last, and I've got two medians, so it's 136 and 138. So I add them together and I divide by 2, and I get an answer of 137. So clearly the median of the diesel engines is lower than the median of the petrol engines. And likewise, to get the mean of the petrol engines, I add up all my values. So I'm not adding 9 plus 9 plus 9 plus 3. I'm adding 129 plus 129 plus 129 plus 133 plus 134 and so on. Add them together, divide by 12. And again, you will end up getting a lower median for the diesel. A lower mean for the diesel. So yes, the diesel engines grouped at the top of the plot have a smaller median or mean value. Does the information suggest that there is a greater variation in the CO2 emissions, carbon dioxide emissions of diesel engines than petrol engines? In your answer, you should refer to the stem and leaf plot and an appropriate measure of variability. So again, we're going to have a look at our stem and leaf plot. So does the information suggest, so does the stem and leaf plot suggest that there is a greater or bigger variation in the CO2 emissions of diesel engines than petrol engines? So is there a bigger variation or a greater variation? And the answer is no. The emissions for petrol engines are more spread out than for diesel ones. The range for petrol engines is greater than that for diesel engines. So the range is where we take the largest value and we minus the smallest value. So the lowest diesel value is 107 and the largest is 134. So 134 minus 107 gives us a range of 27. And the lowest petrol value is 129. The highest is 159. And 159 minus 129 is 30. So the range for petrol engines is 30. So the range for diesel engines is 27, which is lower than the range for petrol engines. So the range for petrol engines is more spread out. So a larger range, a bigger range, means it's more spread out than the diesel ones. We can say the same for the interquartile range. So if we get the interquartile range of the diesel engines and the interquartile range of the petrol engines, again we will see that the petrol engines are more spread out. And likewise, if we got the standard deviation of the diesel engines and the standard deviation of the petrol engines, we again would see that the petrol engines are more spread out. Now for videos on how to find the interquartile range of a set of data or the standard deviation of a set of data, have a look in OL Statistics playlist.